at lesson 71. We're going to look at lesson 71 and 72. They're very different lessons, but they're pretty basic lessons overall. Lesson 71 is translations. If you remember a little ways back, we had our introduction to transformations lesson in which we talked about translations, reflections, and rotations, which are all isometric. Today we're going to be talking specifically about translations. Most of what you find in your book is just going to be a matter of definitions. In a definition, a translation shifts every point of a figure the same distance in the same direction. So we're going to look at this in terms of, moving every single point of a figure left or right so many points or so far, and then up or down so far. All right, a figure that is transformed by translation remains congruent to its preimage. That is the definition of an isometry. Its side lengths, angle measures, other properties remain the same. Translation changes nothing but the location of a figure. In fact, it doesn't even change the orientation. Okay, the orientation, it should look, the top should be the top, the bottom should be the bottom, the sides will be the sides. It looks exactly the same other than it has just been moved. Okay? All right. From there, just tells you that a translation is an isometry, meaning that the preimage and its translated image are the same size and shape. So the two figures are congruent to each other. Okay, then we get into lesson 72. Okay, lesson 72 picks up on page 477. And we're going to talk about tangents to circles, and this is actually the second part to this. A tangent to a circle is a line that touches a circle at exactly one exterior point. So if we read that, tangent line that intersects the circle at exactly one point, the point of intersection is called the point of tangency. Common tangency is whenever a tangent to two circles, so one line, tangent to two circles. So it's going to touch two different circles at one point, okay, on each circle. Common tangents can be internal tangents or external tangents, in which case I'll show you an example of internal and external. That's an example of an external common tangent. So we're seeing this top line comes across, touches this first circle at exactly one point. Okay, keeps going, touches a second circle at exactly one point. Okay, then we have a second one. Okay, touches those circles there and there. It's tangent lines. Okay, so far pretty basic, pretty easy. Okay. All right, so that's external, meaning the lines are on the outsides of those circles. Then we have common internal. Internal common tangents are where we're going to see where they cross each other. So we're going to get that point of tangency with this. We're going to get this point of tangency with this over here. And there are different properties to this. What we should notice about this, what they'll tell us later, is that they're going to break these into congruent segments. Okay? But beyond that, we can also get circles that are tangent to each other, meaning I can have an internal tangent circle where a circle touches another circle at exactly one point, with one circle being inside the other. And then we have external tangent circles where one circle is outside but still touches a circle at exactly one point. Okay, externally tangent circles. Tangent circles are coplanar, meaning they're on the same plane. They intersect at exactly one point. Tangent circles can be internally, like what we saw earlier, or externally, like what we see here. In both cases, the radii of the two circles are collinear. Okay, that's an important thing to see. We can go back here. The radii are on the same line. Okay, so if I see, this radius here, okay, that radius there is going to be on the same line. Okay, we understand that, hopefully. Obviously, my center point on that larger circle is not exact. Okay, here, if I draw a radius here, or center here and here, they're on the same line. Okay, they're collinear. All right, from here, let's start working out some questions, and we'll see how far we get. I didn't already have these pulled up. Like I said, it's been a busy morning. 71 and 72. We went a little too far. There we go. All right, so we're going to double back here and we're going to look at translation again. Okay, it says draw the image of a triangle with vertices 1, 3, 2, 5, and 4, 3, then perform the following translation. We want to go just 6 units down. So the first thing we want to look at is we actually want to graph the coordinates that they give me, 1, 3, 2, 5, 4, 3. All right, so as we look at this, 1, 3. Okay, does that look like it's going to be in, obviously we're not going to go with graph A, right? Okay, but let's keep it here. Let's go 2, 5. Let's see something like that, and 4, 3. Okay, so we should wind up there, which should match. So far it looks like it matches either C or D, correct? Okay. All right, we want to go 6 units down. So I'm going to take every unit 6 units down. So 1, 2, 3, 4, 5, and 6. Thank you, Aaron. I'll try to get your score released to you by the end of the day, okay, and have that graded and back to you if you want to come in during Aware and pick it up, okay? And those, we're going to go every individual point is 6 units down. So if on this next one, I'm going to go 1, 2, 3, 4, 5, 6. And in the next one, 1, 2, 3, 4, 5, 6. Okay, so I should wind up with something that looks like that, which I believe, what does that match up with as far as what we can see? Matches up with C. Good. Okay, so everything moves independently 6 units down. Okay? All right. Let's see what else we've got. 2, find the coordinates of the image of E, F, G after translation, x minus 6, y plus 2. So this is our translation notation that we see right here. It's going to tell me what I'm going to do with each of the coordinates. So what this means is I'm going to go 6 units to the left, 2 units up. Okay, look at your x minus 6. That's how I know I'm going left. Does that make sense to us? Okay, y plus 2. Well, y is a vertical component, so we're going to go 2 up. So take our e, okay, 1, 2, 3, 4, 5, 6, up 2. So this is e prime. Okay, then everything else, f, 1, 2, 3, 4, 5, 6, 1, 2. Okay, so this is going to be f prime. And then g, 1, 2, 3, 4, 5, 6, 1, 2. Okay, so that's my g prime. Okay, you'll see that it looks as though it's parallel with the first one. It should always look as though it's run parallel. Okay, notice that our orientation hasn't changed. It's the exact same size, it's the exact same shape. All my side links are congruent, all my angles, all my corresponding angles are congruent. Everything's the same. Translation should be the easiest transformation that we do. Okay? Does everybody understand the x minus 6, the y plus 2, and how I understood that we were going 6 left, 2 up? Okay? All right, good. Okay, so I'm less concerned with the multiple choice options as I am you understanding. All right, B, a point B, 3, 8 is translated 4 units to the right. What are the coordinates of the new image? So, we really don't have to do a lot here. We don't have to draw this on the coordinate plane. We're going to look at 3, 8 just by itself. 3, 8. What does 3 represent? What kind of value? It's my x value, which is my horizontal movement, correct? Okay. And 8 represents what value? Y value, which is what kind of movement? Vertical, up and down. Okay. So if it says 0.38 is translated 4 units to the right, which one am I moving? Am I moving my x value or my y value? X. Okay. So if I'm moving 3 units to the right, am I adding or subtracting? Adding. So if I'm moving 4 units to the right, what is my new coordinate from 3? 7. Okay, 3 plus 4 is 7. What about my y value? Stays the same because we didn't move up or down. Okay, so we want 7, 8. B prime is going to be 7, 8. We follow so far? Okay, it's pretty basic math up to this point. Okay, we're going to switch gears and we're going to look at lesson 72 for question number 4. Okay, in this diagram, QR is a tangent line, meaning it comes out here, it touches circle P at exactly 1 point. Determine the area of triangle PQR to nearest tenth if circle P and circle Q are congruent tangent circles with a radii of 10 units each. So the circles are the same size, right? And their radius is 10. Could I go ahead and write in 10 everywhere where I have a radius? Okay. So let's see. From here to here is 10. From here to here is 10. From there to there is 10. From here to here is 10. Does that make sense? Okay. I've just put a 10 wherever I had a radius. Now I want to know the area of this triangle. In order to find the area of a triangle, what formula do I use? Anybody know? How do I find the area of a triangle? Any triangle. Base times height divided by 2. Now, what do I know about a tangent line and a radius? They always meet at what kind of angle? A right angle. So I'm going to put a right angle right there. Okay? You follow me? Now, in order to find this, I need to know 2 things. I need to know the base, and I need to know the height. Now, does the hypotenuse ever represent the base or the height necessarily? No. It's much easier in a right triangle to use the other 2 legs, right? The other 2 legs should always represent the base and the height. So what length or what segment represents the hypotenuse in this triangle? Not RQ. RQ is not the hypotenuse. PQ. Okay, so I can't use 20, right? All right, so, but do we have any idea what my base might be? 10, right? Which is what length, Brady? RP. So he's saying RP is the base. Okay, so let's put that up there. 10 divided by 2, which means which length is going to represent the height? RQ. Do I know the length of RQ at this point? Okay, but do I know enough about this triangle in order to find it? Okay, what formula do I want to use in order to find it? Pythagorean theorem. Tell me how to put that together. Equals 20 squared. Very good. All right, so we've got 100 plus b squared equals 400. Okay, what does b squared equal? 300, because we're going to subtract 100 across. What do I need to do with 300? Square root it. Okay, and we're going to get a decimal out of this. So what is the square root of 300? $17.32. Okay, let's take that 17.32 and multiply it by 10 and then divide it by 2. I've got a calculator in here. 10 times 17.32 divided by 2. Okay, what did you get? Anybody? 86.6. 86.6, and for whatever reason I can't find my paper for it. Oh, here it is. Okay, so let's take a look at that question. Let's make sure we got it right. And we should get 86.6. Okay? Now, hopefully we're working this out. You know, I mean, you may think this is an easy lesson, but I would be working these problems out and making sure that I understood some of this stuff, okay? The easiest thing to do is to decide, hey, this is easy, and get it on day 1, and then on test day, it's completely gone, all right? We're long past it. Okay, let's look at number 5. Okay, translate the triangle with vertices 3, 4, 2, -1, and 4, 12 along the vector -1, 3, find the coordinates of the new image. So we're talking about a vector notation. All right, vector notation. What does -1 tell me that I'm doing? From every position, what am I doing if I have -1 up there? Moving to the left 1. That's absolutely right. And what does 3 tell me I'm doing? Moving up 3. It also tells me that if I'm just looking for the coordinates, that on every one of these x's, I'm going to subtract 1, and on every y, I'm going to add 3. Does that make sense? Okay? So as we look at A, right, what am I doing with 3? It should become 2, and 4 will become, all right, so I should get 2, 7, right? Okay, 2, 7. Let's come over to B. What am I going to do to 2? Subtract 1, so I'm getting 1. What do I do with -1? Add 3, so do I get 2. So I should get 1, 2. All right, so far this is matching up with what we see here and there. Okay, which at this point, you know, you would know the right answer, but let's make sure that we continue to understand it. What do I do with 4 on C? Subtract 1, it becomes 3. What do I do with 12? Add 3, it becomes 15. Are we understanding how it's just simple math? We don't have to draw, we don't have to put this all in a coordinate plane and do everything that we've got to do if we understand how vector notation works, if we understand how translation works. Okay? Okay. Number 6. Number 6 tells me we're moving from 1 to 2. It wants to know what type or what is the translation notation. So we've got xy moving to x plus or minus y plus or minus. So x, y. So if we're going, the easiest thing to do is to pick a point and follow it left or right, then up or down, right? Okay, so am I going left or right from 1 to 2? Left. That should tell me that's going to be x minus, correct? Okay, and am I from here to this next point up here, am I going up or down? So my y should be what, plus or minus? Plus. Okay, so now we just need to count. 1, 2, 3, 4, 5, 6. Okay, so x minus 6, right? And then up, 1, 2, 3, 4, 5, 6. So every position is going to go 6 to the left, 6 up. Okay? The other way of doing this, if you wanted to do it this way, you could have just plotted that coordinate. That is 1, -1. Come over here, we've got 1, -1, 2, 3, 4, 5. Up, 1, 2, 3, 4, 5. If I know that's 5, 5, what takes me from 1 to 5? Well, or sorry, -5. From 1 to -5 is -6. From -1 to 5 is +6, right? Okay, just in terms of distances. So it's more than one way to do that. Okay, but for most of us, it's going to be easier to just count left, right, up, down. Okay? All right. Now let's come down here. We'll get back into some lesson 72 stuff. We see the same type of question show up again, except I don't, we do still want to find the area. All right, in this diagram, triangle A is, again, tangent to circle C. BD is tangent to circle A. The radius of circle A is 7. Only in this case, they're not the same size circle, right? So we can go ahead and fill in some 7s. Anybody can tell me on which line I can put 7? AB. And from A to the end of the circle, right? So from here to here is 7. Okay? And the radius of circle C is 4. So C to D is 4. And C to the end of the circle there is 4, correct? Okay, now we don't know the length of BD, but if BD is tangent to circle A, what do I know about angle ABD? It's a right angle, okay? Because the tangent line and a radius will meet at a right angle, right? Okay, so if we want to find the area, same formula again, base times height divided by 2. Okay, what's my base in this question? 7. Do I know the height? No. Okay, so what formula do I use to find it? Pythagorean theorem, help me set it up. $15 squared. Good job. Okay, 7 plus 4 plus 4, or 7 plus 8 is 15. So we've got 49 plus b squared equals, is that 225? Some of them you get to where you memorize a little bit. 225. Okay, so what's 225 minus 49? 176. All right, what do I want to do with 176? Square root it. Okay, what does that equal? 13.3, I'm told. 13.3. Okay, we want to find the areas to the nearest square meter, so the nearest whole. So we want 7 times 13.3. Divided by 2. Yes, I'm getting like 46.55, which should be, what's that? Yeah, so this is what we're going to do instead. Instead of putting 13.3 in here, what I'm going to do is, and I'll show you with the calculator how our answer comes out a little bit different. All right, we'll see if mine comes out. 7 times square root of 176. Okay, divided by 2. Okay, gets 46.4, which is what we want because we want to the nearest whole. If I do 13.3, I think 13.3 is around. Did you round up to get 13.3? And that's enough that if you were rounding to the nearest square meter, rounding 13.3 or rounding up to 13.3, you would have written down 47 instead of 46. Right? At 46.4, we ran down to 46. Okay? So it's a little bit of a tricky place. So we want 46 meters squared for that answer. All right, number 8, a little different. We haven't run across some of these internal tangent lines just yet. Okay, I think we've only got 2 questions left. We may have enough time for you guys to even get started today. All right, in this diagram below, AD, BC are internal common tangents. To circle E and circle F, we want to find the lengths of AG, okay, this length right here, and BG, okay, this length right here, okay? All right, so I don't know if this is something that they say in the book. I'm not sure that I came across it, but these segments, like I showed you, are going to be the same length. All right, so the easiest place to start with is finding out what x equals. Can I see from this what x equals? What does x equal? X equals 9 because GC is congruent to GD. If I know GD is 9, then x, which is GC, must equal 9, right? So x equals 9. If I want to find out what AG is, what do I have to do? Substitute, right? Substitute 9 in for x. 2 times 9 minus 5. 2 times 9 is 18. What's 18 minus 5? 13. So AG is 13. And what should BG be? 13. Well, check it. What's 9 plus 4? 13. Now, let's say we didn't have measurements for GC and GD. I could have said 2x minus 5 equals x plus 4, solved for x, plugged x back in, correct? All right, so there's more than one way to do that. Just we want to find the shortest way possible if we can, and if we have a direct x to number answer, then we just plug it in, right? So 9 plus 4 is 13. Both equals 13. Okay, last question of the day. Okay, a machine system of 2 pulleys and a belt is shown below. Find the length of the belt between A, C, B, and D, D, and E. So it wants to know all these different lengths. All right. Well, the other side of this is also true, that this length is going to be congruent to this length is going to be congruent to that length. Okay? All right, so the easiest thing to do is to set an equation equal to another equation. Which equations would we set equal? Easiest to do. CE and DE, that's absolutely right. So 7x plus 3 equals 24. Okay, subtract 3. 7x equals 21. Divide by 7. X equals 3. So we want to find DE. So actually, we already know what DE is, don't we? We already know that that's 24. So we've got this one. All right, the other one they wanted was B and D. So what do we need to do here? Okay, so 14 times 3. Anybody? 42 minus 3. 42, I'm sorry, I said 3, didn't I? 42 minus 4. 38. Do I need to plug x into AC, or do I already know what it equals? Should equal 38, right? Okay, now you can test it. 12 times 3 is 36. 36 plus 2 is 38, right? So I get 38, 38, and 24. Okay, this 6x here is just really meant to throw you off the trail, right? You think that you're going to use it and don't actually need to. All right, that is it as far as this goes. I'll hit stop on this. Aaron, you can go back and watch the beginning part of the notes if you need to.